Now see, this is the problem that given in examination. So we have capacitors. Take this is B, this is Q, this is R, this is S. Check it is balanced or not. The bridge is balanced or not. P by Q is equals to R by S. This is 3 by 6 equals to 4 by 8. This is once, this is twice, this is once, this is twice. Now we can remove this capacitor 2. Now 3 and 6 are connected in series and 4 and 8 connected in series. Means we can write the equivalent diagram. This is 3, this is 6. This is 4, this is 8. 3, 6, 4, 8. Now these two are in series, these two are in series. 3 and 6 series means we have the formula C1, C2 by C1 plus C2, it becomes 9. 2, 3 is it becomes 2. I'm taking this as C1. So C2 equals to 4 into 8 by 12. 4 1s are 4 3s are. So it becomes 8 by 3. Now C1 and C2 are in parallel. So we can write CAB equals to C1 plus C2. So it becomes 2 plus 8 by 3. So this is 6 plus 8 by 3. It becomes 14 by 3. Everything is micro, so answer is microfarad. Next, 3 capacitors we have here. 2, 3, 6 are joined in series. What is the minimum effective capacitance here? Minimum effective capacitance means we should connect it in series. So we should connect it in series. So 1 by CS. So minimum value, if you see, when 2, 3, 6, 3 capacitors is there, when we connecting in series, among the 3 capacitors, which is the least capacitance value, the answer should be always less than that value. So this is wrong. This is also wrong. Okay. So we can use the technique and eliminate the 2 options. So equivalent capacitance should be always less than the smallest capacitance value. So this is 1 by 2 plus 1 by 3 plus 1 by 6. Here 6 is LCM. 2 3s are, 3 2s are, 6 1s are. So CS equals to 6 by 6. It becomes 1 microfarad. So answer is option B. Next, the charge on the given capacitor, here they ask means, first charge means, here they ask charge. Now how these two are connected? Parallel. These two are connected in parallel means 1 plus 5, it becomes 6 microfarad. 6 microfarad means we can write the equivalent diagram. This is 4 microfarad. This is 6 microfarad. And one more we have, this is 3 microfarad. And given here 10 volt. Now 4 and 6 connecting in series. These two are connecting in series. So when this combination is connecting in parallel means here 10 volts is there, here also 10 volts is there. So we have to find out the charge on 4 microfarad means in enter this branch, the charge here if you take Q1, here if you take Q2. Q1 is common. Q1 we can recognize. So equivalent capacitance in the branch means 4 into 6. By 4 plus 6 it becomes 10. So it becomes 24 by 10. This is the equivalent capacitance. Now Q1 is equals to 24 by 10 into 10 micros is there. So answer is 24 microcoulomb. 24 microcoulomb. So we have to find out the potential is same. So we can multiply. First, we have to find out the equivalent capacitance of that branch. The branch charge is same. Why? Because these two are containing series. Next, here, the given one diagram, the voltage they given as 1200 volts and point A and point B is earthed. Here they given as 120 volt. Here point B, voltage is 0 volts. Now, what is the voltage at this point? Now, first, let me conclude these two. These two are connected in parallel. Parallel means this becomes 6 microfarad. So we can write the equivalent diagram. This is 3 microfarad. Right here. This is point B. And this is another, this is the point B, 0 volt. Here we have 1200 volt. So it will take C1 means this is V1. So this I think 4 plus 2 becomes 6 microfarad. So whenever they ask potential at the P means we should take V2. V2 formula we have C1 into V by C1 plus C2. V how much? This is C1. This is we can take as C2. So V2 equals to C1 is 3 micro means 10 power minus 6. Voltage at the point here is this is one more zero is sorry 1200 by C1 plus C2. 6 plus 3 9 micro. This micro get cancelled. This is 3 ones are 3 threes are. It becomes 400 volt. So answer is 400 volt. Why? Because out of 1200, if you take the ratios of this, we have the relation V1 by V2 is equals to C2 by C1. Means when the capacitance value is more, it will store less voltage. First capacitor is 3. And the ratio, if we take C1 and C3, it is 1:2. So here 2 parts is there, here 1 part is there. 1200 by 3 means it will store 400 volt. Okay, 1 part is 400 volts. Here it will store 800 volts. Why? Because here capacitance is less. So it will store here. Here it is 800 volts it will take. So 1200 minus 800 it will use 400 volt. Okay. Right. Next, 2 capacitors of capacitance 2 microfarad and 3 microfarad are joined in series. Out of the first capacitor is at 1000 volt and out of the plate of the second plate is at. Now the potential of the inner plate to be asked. Same thing. One they given, the second one we have to find out, we will get the answer. Okay. Next, the series combination of 3 capacitors of capacitance 1 microfarad, 2 microfarad, and 3 microfarad. This is C1, C2, and C3. C1, C2, and C3. Is connected to the battery of 13 volts. The potential difference across the 2 microfarad they are asked. Means, so equivalent diagram if you want, we can write the diagram like this. 1 microfarad, 2 microfarad, 8 microfarad. Voltage they given as 13 volt. This is V1, this is V2, this is V3. So we can write this problem in 2 different ways. First we should find out the charge, then after we can find out the potential. Otherwise we can use the formula. They ask potential difference across the 2 microfarad. So we want V2. V2 formula we can write V2 is equals to 1 by C2 into V by 1 by C1 plus 1 by C2 plus 1 by C3. This formula we can use. Or otherwise, if you take 1 by CS is equals to 1 by 1 plus 1 by 2 plus 1 by 8. So LCM is 8. This is 8. This is 4. This is 1. So CS is equals to, we have 8 plus 4, 12, 12 plus 1, 13. 8 by 13. This is total capacitance, total charge, CS into V. CS is 8 by 13. V they given as 13. 13, 13 get cancelled. Total charge is 8 micro coulomb. This is the total charge. Now all the capacitors are connecting in series. So 8 microcoulomb is equals to 2 microfarad into voltage V3 or V2, second law V2. So V2 equals to 8 microcoulomb by 2 microfarad. Micro get cancelled, becomes 4 volt. If you use this formula also, you will get same answer. This is shortcut we can use. This is the general method, okay? Next, a capacitor of capacitance C1 charged to potential V and then connected to the uncharged. So here, this is the important point. Uncharged means we should take V2 equals to 0. Then the final potential difference across this means common potential formula we have C1 V1 plus C2 V2 by C1 plus C2. Here V2 0 means this part becomes 0. So V is equals to C1 V1 by C1 plus C2. So option C is the correct answer for this. So whenever they give an uncharged here, for this problem, this is the key point. Whenever to give an uncharged, which is equals to 0. Next, 3 capacitors of capacitance 3 microfarad. So all are identical capacitors. The maximum and minimum. Maximum means we should connect it in parallel. Minimum means we should connect it in series. Identical capacitors, parallel formula N times of C. So N is here, number of capacitors. This is N, this is C. So answer 3 into 3 microfarad, it becomes 9 microfarad. This is maximum. So minimum means we should connect it in series. Identical capacitors series formula C by N. C is 3 microfarad by 3, it becomes 1 microfarad. This is 9 microfarad, this is 1 microfarad. This is now see the equivalent capacitance or effective capacitance between A and B if all are having the same. Between A and B they are here. So these two are connected in series. Series means it becomes C by 2. These two are connected in series. These two becomes C by 2. Now we can write the equivalent diagram. This is point A. We have one capacitor. This is B. Its value is C. So here we have one capacitor. This value is C by 2. Here we have one capacitor. This value is C by 2. Now all these three are connected in parallel. So CAB equals to C plus C by 2 plus C by 2. C by 2 plus C by 2, it becomes C plus C, it becomes 2C. Now, the 4 equivalent capacitors, the 4 equal capacitors of capacitance we arrange as on equivalent capacitors between A and B. Now, these two are connected in parallel. So, parallel means C plus C becomes 2C. Now, we can write the diagram. This is one capacitor C. This is one capacitor 2C. This is A. Now they connected one more capacitor here, C. This is B. Now these two are in series. Series means 2C into C by 3C. C get cancelled, becomes 2C by 3. Now this diagram we can write, equivalent diagram. We have two capacitors. This value is 2C by 3. This value is C. These two are connecting in parallel. Parallel formula C1 plus C2. So 3C plus 2C becomes 5C by 3. So option C is the correct answer. So equivalent capacitor they ask. Similarly, these two are connecting in parallel. Parallel means it becomes 4 microfarad. Yeah. Now they ask between A and B. So it becomes 4 microfarad means this 4 connecting in series. This 4 connecting in series. 4 connecting series means it becomes 2 microfarad. This 4 connecting series becomes 2 microfarad. This 2 connecting in series it becomes 4 microfarad. Okay. So we get the option like this diagram. Yes. These two microfarad and these two microfarad. These are all connecting in parallel. So answer becomes 4 microfarad. Okay. Next. So the equivalent diagram, the charge on 2 microfarad capacitor they asked. These two are connecting in series. These two are connecting in series. Series means the equivalent diagram becomes this is 1. This is 1 capacitors. This is 2 volts. 2 to series means becomes 1. So now this is 1 microfarad. This is 1 microfarad. This is 2 volts. These two are connecting in parallel. So here voltage is 2 volts. Here also voltage 2 volts. Then the charge formula Q is equals to C into V. So C is 1 microfarad into V is 2. So it becomes 2 microcoulomb. The charge on any one of the 2 microfarad and 1 microfarad. So charge two microfarad is 2 into 1 microfarad becomes 2 microcoulomb. Then hi students, today we will discuss about capacitors problems. Part 2. See, this is the problem they given. A capacitor of 10 microfarad charged up to the 220 volts connected in parallel to the another capacitor. See here, this is one capacitor they given C1, this is V1, and another capacitor, this is C2, and this is V2. Then the common potential they ask. So common potential formula we have common potential equals to C1 V1 plus C2 V2 by C1 plus C2. So C1 is 10 into 250 micro, we can write 10 4 minus 6 plus C2 is 5 into 100 into 10 power minus 6 by C1 plus C2 means 10 plus 5. It becomes 15 into 10 power minus 6. So minus 6, 10 power minus 6 common, cancel each other. It becomes 2500 plus this is 500 by 15. So it becomes 3000 by 15. So it becomes 200 volt. So answer is here. Option 4 is the correct answer. 200 volts. Clear? So the next problem, if you see two identical capacitors having a charge. See, both are capacitance C only, means we can take C1 and C2. Both are given as identical capacitors means C. One is charged to the potential V1 and another one is V2. The negative ends of the capacitor connected together when the positive ends are also connected together. The decrease in the potential energy they ask. So decrease in the potential energy means we have the formula loss in potential energy formula half C1 C2 by C1 plus C2 into V1 minus V2 whole square. So delta U we can write half C1 C2 means it becomes C into C and C1 plus C2 means C. This is V1 minus V2 whole square. So this one one time get cancelled. So delta U equals to 1/4 C V1 minus V2 whole square. So option is so we want 1/4 C V1 minus V2 whole square. So option C is the correct answer. So here it is not correct. It is not correct. Yeah. Yeah. Two capacitors of capacitance 3 microfarad and 6 microfarad. So this is C1, this is C2. So mark it as this is C1, this is C2. Are charged to the potential of 12 volts each. Means both are given same voltage V1 and V2. They are now connected to each other with positive plates are joined together and negative plates are connected together. Means we can use the same formula like previous problem. Delta U is equals to half C1 C2 by C1 plus C2 into V1 minus V2 whole square. So here no need to do the calculation part here. If you take both are charged to the potential to the voltage 12 volts means, and in problem they mentioned V1 is equals to V2 equals to 12V. So here in term if you see delta V how much is 0. So answer you can take directly 0 only. Okay. I think it's clear. Next, three capacitors we have 2, 3, 6 are joined in series and combined is charged by the means of 24 voltage. Then the potential difference between the plates of the 6 microfarad capacitor they are asked to see. According to the problem, they given three capacitors. So we have three capacitors here. So potential they given as 24 volt. So it is positive terminal. This is a negative terminal. This is 2 microfarad and this is 3 microfarad and it is 6 microfarad. And we know that when the capacitors are connecting in series, charge is constant and it will have a potential V1, this is V2 and this is V3. So in problem they ask what is V3 value they ask. So we have two formulas, two ways we can find out the answer here. So first up we can go for the general method, then I will explain the shortcut form for this. Okay. So first when these three capacitors are connecting in series, charge is constant. So we have to find out what is effective capacitance. 1 by CS equals to 1 by 2 microfarad plus 1 by 3 microfarad plus 1 by 6 microfarad. So LCM is 6 here. So this is 2 3s are, 3 2s are, 6 1s are. So CS equals to 6 by 6. It becomes 1 microfarad. Okay, 1 microfarad. And when we are connecting in series, we know charge is same. Charge Q is equals to CS into V. CS value is 1 micro, means 10 power minus 6. Voltage is 24. So charge, total charge is 24 microcoulomb charge is there. Means if you take any capacitor, it hold 24 microcoulomb charge. Now they ask V3. We have the formula Q is equals to CV. So V we can replace V equals to Q by C. While they're connecting in series, every capacitor have holding the same amount of the charge, that is 24 microcoulomb. So they ask what is the capacitance, what is the value of the capacitance they given? 6 microfarad. So that we should take in denominator. So we can take here 6 microfarad. So microfarad will get cancelled. 6 ones are 6 fours are. So answer is 6 volt. So answer, this is the answer. So instead of doing all these things, so I will give a small shortcut to find out whenever the capacitors like this. They ask V3. So V3 formula equals to V into total voltage into 1 by C3 by 1 by C1 plus 1 by C2 plus 1 by C3. If you use this formula, you will get the answer. Suppose if they ask V2, here 2 will come. If they ask V1, you can use here V1, here C1. Okay? Right. The next one. So in the diagram, if you see the given 4 capacitors, I think it's a repeated model, so no need to solve the problem here. The given in the problem all are 4. So this is 4, this is 4, this is 4, this is 4. Okay. So we can use the balancing Wheatstone bridge condition. Suppose if you take this is P, this is Q, this is R, this is S. So what is the condition of balancing Wheatstone bridge? P by Q equals to R by S. So P by Q means here 4 by 4, S by R by S means 4 by 4. So it is a balancing bridge. So balancing bridge, now this PQ, P and Q in series and R and S are in series. So if you want the diagram, this is P, this is Q, and this is R, this is S. This is given as 4, this is also given 4, this is also given as 4. So this is A, this is B. 4 connecting in series, it becomes 2 microfarad. These two connecting in series, it becomes 2. Now 2 connecting in parallel, so it becomes 2 plus 2, this is 4. Actually, no need to solve all this process. If all capacitors value is equal, means PQRS values are same. So answer will get the same thing. So here all values is 4. So answer you will get 4 microfarad only. Okay. So this is useless. We can remove the capacitor. Why? Because when the bridge is balanced, there is no charge passing across the capacitor C2 here. Okay. Now see the equivalent capacitance between A and B they ask. So how these two are connected? These two are connecting in parallel. Parallel means 4 plus 4 it becomes 8 microfarad. Now the equivalent diagram if you want I will write here. One side is A. This is 2. This is 3 microfarad. This is 3 microfarad. And now this is becomes 4 plus 4 it becomes 8 microfarad. And this is 2 microfarad. And this is 3 microfarad. Another end is B we have. Now instead of using 1 by C1, 1 by C2, 1 by C3, 1 by C4. Now see this 2 connecting in series. These two becomes 1. And 3 connected in series. Or otherwise we can use the formula 1 by CS is equals to 1 by 2 plus 1 by 3 plus 1 by 2 plus 1 by 3, 1 by 2, 1 by 3, 1 by 8. So I think I forgot 1 by 8. Or 1 by 8. Yes, yes. So 1 by 2 plus 1 by 2, it becomes 1. 1 by 3 plus 1 by 3, it becomes 2 by 3 plus 1 by 8. So 1 by C equals 2. So LCM is here 24. This is 24. This is 16. This is 3. So 1 by C equals to, it becomes 24 and 16, it becomes 40, becomes 43 by 24. Now they ask C, so answer is 24 by 43. So option B is the correct answer. Okay. Now here we can eliminate a few options, option A and option B. Option A and option B, if you take among the given capacitors, the least value is 2 microfarad. If you calculate when they're connecting in series, the answer should be less than 2 we want. So option 1, 24, 2 is a 48. So this is the way we can solve the problem. Okay. Next. What is the equivalent capacitance from the given diagram? See, these three are connected in series. These two are connected in series. So I can write the equivalent diagram. This is A. So we have a capacitor. These three are connecting in series means this value is C by 3. Now, this is connected to, this point is connected to B here. Means we can shift this capacitor to the top. Like this is C. Now we can take it as B. Now these two are in parallel. Parallel formula we have C1 plus C2. So C plus C by 3. It becomes 4C by 3. So option D is the correct answer. So first, these 2 or 3 are in series. Later, we can shift the capacitor. So why? Because there is no other capacitors here. The total we can connect it here. No? This. A parallel plate capacitor has the capacitance C if it is equally filled with the parallel layers of material of dielectric constant K1 and K2. Then the C becomes the ask. A parallel plate capacitor have the capacitance how much is given? C. If it is equally filled with the parallel layers of the material K1 and K2, means you have to understood here. We have one capacitor here. So this is A and this is B. Now these two are filled with the two dielectric materials. The given parallel layers of materials equally. Equally means this is distance d by 2, d by 2. So you may have doubt, why should we take only like this? The given parallel plate capacitor has the capacitance say if it's equally filled with the parallel layers, not perpendicular layers. Okay. Perpendicular means we can divide the area. So, but here parallel layers are given up. We should divide the only the distance. Okay. So, this is area A. This is also area A. So, it's having the dielectric constant K1 and it's having the dielectric constant K. Okay. Now, these two are connecting in series. Okay. First, let me complete for C1 is equals to K1 into epsilon naught A by D. D value we have D by 2. So, it becomes C1 is equals to 2K1 into C0. Similarly, if you take C2, we have 2K2 into C0. Now, these two are connecting in series. These two are connecting in series. Series formula we have CS is equals to C1, C2 by C1 plus C2. C1, C2 by C1 plus C2. So C1 is 2K1 into C0. C2 is 2K2 into C0. So if you can add these two C0 is common. So we have K1 plus K2. Clear? So this C0 get cancelled, 2 one time get cancelled. It becomes 2K1 K2 by K1 plus K2 into C0 into C0. The ratio, and if it is completely filled with K1, the capacitance becomes C1. The given is C1. Now before it is C, parallel plate capacitance C0 if we take means C1 equals to C into 2K1 K2 by K1 plus K2. Now in a problem they ask C1 by C. So C1 by C equals to. Now, hello, this. So this is the answer for this problem. So